Okay, before last time we learned to calculate the multiples of intervals that aren't augmented or diminished. Here are the rules we follow to determine the multiple of an interval. And here are some examples of the computations we did in the before last video, etc. Last time we explored even numbers. Using them we figured out how to compute the multiples of minor seconds. We easily multiplied minor seconds in these examples. Beside ourselves with excitement, we use our newfound superpower to multiply intervals that were diminished or augmented. Basically, all you need to know is this. The diminished interval, the eighth interval, diminished eighth interval is equal to the eighth interval minus a minor second. By definition, that's how we defined it. And this one, that the augmented eighth interval is equal to an eighth interval plus a minor second. And that's how we defined it. You could read that off the piano. So a diminished eighth interval times m is some number, is equal to the eighth interval times m minus you just distribute it, the m, the minor second times m. And the augmented eighth interval times n is equal to the eighth interval times m plus the minor second times m. We just added a factor of m. If you can handle multiplying minor seconds, then you can easily get the multiple of the diminished or augmented from the multiple of the unaltered interval. If you diminish, you subtract something. If you augment, you add something. All the other stuff you don't really need to memorize if you can multiply minor seconds. If you know the greatest multiple of a minor second is the minor second times 12, then you could just break it up into octaves with the remainder you could easily handle. Okay. Here are the examples we covered. Remember these examples from way back when? How do we compute them using these new magic tricks? Some of the intervals are way too big for us right now. Here's how we compute the multiple of any interval when we care about chromaticism. As always, reduce the interval of which we are taking the multiple to multiple of an octave plus remainder, if not already smaller than an octave, of course. Multiply the whole thing using our usual non-chromatic rule. If the multiple of the non-octave multiple part is smaller than an octave, apply the strong-weak interval rules. If not, go to step 3. If the multiple of the non-octave multiple part is not smaller than an octave, then rewrite as largest multiple, no larger than an octave plus remainder. Replace each of those multiples with an octave minus the difference. Distribute that. Get a new product and apply this process again until the product is quickly computed. Remember this from the latest fun fact video about divisors of an octave. The blue numbers tell us the largest multiple of the corresponding intervals. If you want to determine the largest multiple of any other interval, it's going to be the blue number of the interval that is immediately larger. For example, if we want to know the largest multiple of a fifth, sixth, or seventh, we just look where they fall between those numbers. Since the immediately larger interval on the list, which is the list of intervals that divide evenly to an octave, to all of them is the octave itself, we know that the largest multiple for all those intervals is the interval times 1, or the interval itself. Similarly, the largest multiple for a fourth is a fourth times 2. And you could also just calculate it from scratch if you don't know it. You can pause the video to see the details of doing that. We basically multiply a given interval till we can't anymore without getting something larger than an octave. Remember, we're only talking about largest multiples for intervals smaller than or equal to an octave. We find that a second times 6 is the largest multiple of a second. Third times 3 is the largest multiple for a third. Fourth times 2 of a fourth. Fifth times 1, sixth times 1. Seventh times 1 are the respective largest multiples of a fifth, sixth, and seventh. So they are their own largest multiples. So the largest multiple are 6 for a second, 3 for a third, 2 for a fourth, and 1 for anything a fifth or higher. And remember, we're not talking about largest multiples for things bigger than an octave. That covers all the largest multiples. Having covered them, we know what to do in every case because we're going to reduce any interval to an interval smaller than an octave or to a multiple of an octave, so we'll always know what to do. Here we run through a couple examples of calculating the largest multiples. You can pause to see the details. You don't really need all these steps. You can skip a lot of it, but I wanted to show the details in case you weren't sure how we got from one point to another. We find that a fifth times 5 is a diminished 21st. Not very far from the estimate of a 21st from our non-chromatic system. That's what we would have gotten. Here are other examples, and here's a quick tip on multiplying octaves. To find multiples of an octave, remember that an octave times 4 is 7 times 4 plus 1, which is a 29th. That is that the fourth times an octave is 1 more than a fourth times 7. So an eighth times 5 is 36, because 7 times 5 is 35. 7 times 9 is 63, so we know that an eighth times 9 is going to be a 64th, just one larger than the multiple of 7. As long as you can multiply 7, you can multiply 7, you can compute multiples of an eighth of an octave easily and recognize them. So we can just have written 8 times 4 is equal to 29th, because 28 is equal to 7 times 4. So after, we find that a second times 25 is a 30th. Finally, we find that an 18th times 4 is a diminished 70th. Remember, when doing these calculations, you can add freely to any multiple of an octave. You don't have to worry about our usual gymnastics then. Thanks for watching. Soon I'll start posting videos about how you can determine if a chord can be played on the violin or a similar instrument like the guitar. This will use the same trick for a large class of instruments, and you can generalize it to other instruments if you know basic things about how it works. Please like and subscribe as usual, and see you next time.